Section 10.1, Real Numbers and Order. If I had to pick one chapter in this course that is perhaps the most important chapter of any in this and subsequent math courses, this chapter would be the one I would pick. The ideas presented in this chapter will be used throughout everything you do in math from here on out. So please make sure you have a firm grasp of the material and ask me questions when you have them. Let me start by talking about some of the different number systems that we have. While you won't be tested on these, it is important as I will be using these words from different times, so it's just good that you know exactly what I'm talking about. There are four different types of number systems that I'm going to talk about here. First of all, the natural numbers. The natural numbers are also known as the counting numbers, and the set of natural numbers just starts with the number 1. And it just goes 1, 2, 3, 4, 5, and goes on forever and ever and ever. As I said, they're known as the counting numbers or the natural numbers because it's just natural that when a young child starts to count, they start with 1, 2, 3, 4, etc. The whole numbers are the natural numbers, but it also includes the number 0. So the whole numbers are 0, 1, 2, 3, 4, 5, 6, and it goes on forever and ever and ever. Integers. The actual definition of integers is the natural numbers, their opposites, and 0. So if I wanted to make a list of the integers, I could, maybe I'll start off here with -6, -5, -4, -3, -2, -1, 0. And then I would go on 1, 2, 3, 4, 5, 6, and I could go on forever and ever and ever in both directions. We will be doing a lot of talk in this particular section about integers, and when I talk about integers, sometimes people just say, oh, you're talking about the positive and negative numbers. And that is true. But I'm not necessarily, I'm not, as a matter of fact, when I talk about integers, talking about rational numbers. Rational numbers, there is an exact definition of it. I'm not going to really get into that right now, but rational numbers, for the most part, are fractions. So 2/3 is a rational number, 5/6 is a rational number. Decimals, because decimals can be expressed as fractions, 0.38 is the same thing as 38 hundredths. So rational numbers are basically fractions, but they're fractions and decimals. And there's more to that, but at least for this particular course right now, that gets us where we need to be as far as what the set of rational numbers are. One other idea that you need to become familiar with in this section is the idea known as absolute value. And I will start to talk about that on the next slide. Absolute value means the distance from 0 on a number line without regard to direction. And absolute value is indicated by having two vertical lines on either side of a number. So for instance, if I were to say to you, what is the absolute value of 3, that is how I would write it. The absolute value of 3 just means how far away is 3 from 0 on a number line, and obviously it is 3 units away. At the same time, what is the absolute value of -3? Well, the absolute value of -3 is also equal to 3 because it is 3 units from 0 on a number line. So just remember, when we talk about absolute value, we mean how far, but it has nothing to do with going in the positive direction or the negative direction. One thing that I see sometimes from some people, if I were to say to you, what is the absolute value of -5? The answer to that is obviously 5. The answer cannot be a positive 5, because as soon as someone puts the positive symbol in front of the 5, they're giving a direction, and that cannot be. Now, the reason I'm talking with you about absolute value at this point is because when we start to add and subtract positive and negative numbers, I'll be using the term absolute value quite a bit. and I just want to make sure that you are aware of what that means. Some of the problems in your homework in this section ask you to use the idea of absolute value when adding or subtracting. So I have 3 problems here. Here's the first one, the absolute value of negative 2 plus 3. Well, I know that the absolute value of negative 2 is 2, so I am just going to rewrite this as 2 plus 3, and I am going to get 5 for an answer. Here's another one. I want the absolute value of whatever 15 subtract 8 is. Well, 15 subtract 8 is equal to 7, and the absolute value of 7 is 7, so I just have an answer of 7. And then finally, the third one. The absolute value of negative 8 subtract the absolute value of negative 7. The absolute value of negative 8 is 8, so I have 8 subtract, and the absolute value of negative 7 is 7. So I have 8 subtract 7, so I get a final answer of 1. All you need to do when you see problems like this is to just go through and rewrite what you have as the absolute value. Rewrite those so you just have numbers without any regard to direction, and then go through and solve those problems. Let me talk about one more idea before we finish this video, and that is the idea of greater than, less than. I'm sure you've seen these particular symbols before. This is the less than symbol. So, for instance, if I have something like 2 is less than 5, that might be the way that I would write that. If I have something that is less than or equal to, I would have something like that. I would have that symbol because this particular symbol underneath means that it is equal to it. The greater than symbol looks like this. So for instance, 5 is greater than 2, so this is the greater than symbol. And then once again, if I have greater than or equal to, I would put a line underneath it, or I would underline it to mean greater than or equal to. So if I have something like negative 5 and negative 3, and I want to put the correct symbol in between those two, well, negative 5 is less than negative 3 because negative 5 on a number line is further to the left of negative 3. If I have the numbers negative 6 and negative 9 and want to put in the correct symbol, well, here's negative 6 on the number line, here's negative 9 on the number line. Negative 6 is further to the right, which means negative 6 is greater than negative 9, and that's the symbol that I would put in there. Remember that using absolute value can change which symbol you are using. For instance, if we had the numbers negative 4 and 1, well, negative 4 is less than 1, so we would use that particular symbol. But how about if I gave you the absolute value of negative 4 and the number 1? Well, the absolute value of negative 4 is 4, so 4 is greater than 1, so I would have to use the greater than symbol. As I mentioned previously, the ideas in Chapter 10 are very important to the rest of not only this course, but all of your other math courses. And this short section is just the beginning. If there is anything I can do to help as you work through the concepts in this section, please let me know. Thank you.